alpha can bind to EDCS and change its structure, so it can bind to monobody. What's more, it can be expressed on the surface of E. coli. So after its expression, we will freeze E. coli to let it lose its activity. Last but not least, this is the chip inside our probe. And so we put E. coli which ER alpha expressed on the surface, and the electrode which monobody binds on into the system. And if there are EDCS in the system, ER alpha will catch them and change its structure so it can bind to the monobody. And when they bind together, the resistance of the electrode will change due to the high resistance of E. coli. Notice that if there are no EDCS in the system, E. coli won't be able to bind to the electrode. Accordingly, we can detect the concentration of EDCS by the change of the resistance of the electrode indirectly, and so that we can detect the concentration of EDCS. And that's all for our experiments design. Now let's welcome Charlie for the hardware of our project.
Hi, my name is Charlie, and I'm gonna introduce our dry lab, which is a system and reactor design. And so for this year's Tsinghua IG project, our main goal is to design a device that can tell the farmer that the water that you're pumping into is safe or not. So consider all these conditions. We have made up two kinds of system. The first one we use EIS and probe, which is equipment that can calculate the concentrations through a biochip. And the second one we develop is we want to make an indicator paper so that when the EDC compounds are connected or we say combined to the indicator paper, the color of it will change, and we will use a camera to capture those photos and read the RGB values of it and to detect whether the concentration is high or low right now. So where are we going to put our device? Here's a farm, but we're going to put it somewhere, right? So we're going to put it in the channel. Come on, where's the channel? Yeah, we're going to put it in the channel. So let's take a look at our filter. And this is the filter which has a valve in front of it, which is controlled by a rod and a motor to like lift it or up and down. And later on our inside there will be a filter. And this will be the section view of it. Okay, so this will be how it works in the field. That we can control it to lift it up or put it down. So, as previously mentioned, there are two detecting systems we are using. The first one is a probe. So it is basically quite the same as the one you use in the lab, but we just replace it with a biochip on the top, so that when you suck the fluid up, the chip will send some raw data readings, and will send those readings to the EIS analyzer, and it will tell us the concentration of it. And the second one is we use the indicator paper, which is the paper, and the color will change, and we use a camera to capture the change of the color, and it will tell us with a microcontroller, okay, so what the concentration right now is. So that we can distinguish different colors and the concentration behind it. So I'll skip this part. This is about the control system design, which we say is a feedback control. And basically, the two ones are quite the same because we want to showcase that our design is highly adaptable to different conditions. But last but not least, I want to emphasize on the model that we're building right now. Yes, we're going to make this one real, and the size of it might be like a table. Is we want to build a farmland, and on top of it, the most important one will be the channel, and we'll put our valve and filter here so that when we want to inject some water, we'll lift up we'll lift up the valve so the water can come in, and if we detected too high concentration of the EDC, we'll tell the valve to close. Oops. Like this. Okay, and that'll be the end of our project. Thank you.
Thanks for Tsinghua University's presentation. And is there any question? AB1. Hi, thank you for your presentation. And I'm interested about, you said your bacteria will express the protein, right? And the protein will catch your target. Then when protein catch your target, the bacteria may to find some membranes, maybe on page 49 or 55. So how can you make sure your bacteria with your target will find on that membrane, not just in your water?
Well, we will have the activated carbon. So basically, the compound will first attach to the activated carbon. So it will just not float around in the system. Thank you.
Any other question? No? Okay, thank you. Thank you, Tsinghua University. And next we'll welcome Shannon University.